welcome to our experiment on resistance. We're going to measure whether the length of a wire changes the resistance in the circuit. I've got a battery pack here running 2 cells running at about 3 volts. I've got my ammeter, which I'm going to switch on. I've got my voltmeter, which is in parallel. My ammeter is also going to be switched. The reason it's switched is so that we don't get overheating on the wire. Okay. We've also got a ruler to measure distance. So here I am, just assessing the situation and making sure that I've got 10 centimeters on the distance of the wire where the connection is made. And I'm now going to check out the volts and the amps for that distance on the wire. So by getting the current and the potential difference in amps and in volts, I can use Ohm's law to calculate the resistance. So to work out our resistance and that's in ohms, what we have to do, everybody, is we have to get our potential difference, which is in what? Volts, and divide it by our current, which is in amps. Okay? Or commonly called I. You can use the Ohm's law triangle, V equals I times R, to help us work out the resistance. You can rearrange this formula in many different ways. V equals I times R, I equals V over R, or R equals V over I. What we're doing, guys, is we're getting the potential difference, which is 0.8, and we're dividing it by 1.83, which is giving you 0.4, and I'm going to go 4 and round to 2 decimal places. So let's take a recording from each of our measurements every 10 centimeters, and I've gone from 10 centimeters to 80 centimeters in my example. So here are my results, and I can represent these results in a graph. And if I plotted my points and drew a line of best fit, it would look something like this. Thanks for watching. I hope it helps with your GCSE exam. And don't forget, subscribe, that'll help. Thanks a lot.